Okay, Umar, so let's proceed ahead with your technical snap for strength of material. And you are going for Jammu and Kashmir Assistant Engineer interview, right?
Yes, sir.
Okay, so Umar, can you tell me something about shear force and bending moment diagrams? Why do we even plot these diagrams?
Yes, sir. So actually, when a beam is loaded in the lateral direction,
Mhm.
this leads to the shear force and bending moment in the beam. Also, because of bending, a beam may fail, so there will be bending stress and shear stress.
Mhm.
We need to know the value of these stresses so that we can design a beam for a particular purpose, bearing a
Okay.
certain quantity of load.
Okay.
This is why, sir, we need these shear force and bending moment diagrams to know the
What
values of.
information do you get from shear force?
Sir, from shear force, we will be able to calculate the shear stress acting on the cross section of the beam.
No, but that knowledge of stresses you can get from bending moment diagram, no? So if bending moment diagram is there, what is the need of having shear force diagram?
But because in addition to the bending stress, shear stress is also developed in the beams. And sometimes it happens that a beam may fail in the shear. So we also need to know the shear stress and hence the shear force for a beam. Because as we know, the shear stress varies parabolically for a cross section. So its value is also important.
अच्छा बीम फेल जो होगा कौन सी स्ट्रेस से फेल होता है उमर?
Sir, mostly the beam fails due to bending stress because bending stresses are actually more. Their strength is more in beams than the shear stress. So if the beam is, it also depends upon the type of loading, which type of. If the beam is loaded, for example, there is no bending moment, it's in pure shear, or if it is only in pure bending. So depending upon that, it will fail based upon that type of external loading.
What do you mean by pure bending?
Pure bending is a state in which a beam or any component is only in the has only the bending moment in it. For example, if we have a beam and it's loaded by 2-point loads that are equidistant from its ends, the beam will have only the bending moment in between these two loads, and there will be no shear force in between. So this is what we mean by pure bending.
Can you give some example of pure bending in simply supported beam?
Yes, sir. Sir, if we have a beam, simply supported beam, and there are two forces, point forces, acting at equal distances from the supports, then the middle portion, the portion within these loads, will be in the pure bending.
अच्छा ये बता सकते हैं पॉइजन रेशियो क्या है?
Yes, sir. Sir, Poisson's ratio is a material property. It is defined by the negative of lateral strain to the linear strain or longitudinal strain. Negative of the lateral strain to the longitudinal strain. That is a material property. Its value varies from 0 to 0.5.
So what is the significance of Poisson's ratio? Why do we even calculate it?
Sir, actually, Poisson's ratio is a material property and many other. If we have to calculate stresses, or if we have to use, for example, in a biaxial state of stress, we have to use this. We use the material properties. And for isotropic material, for example, we need to know at least two properties to find the state of stress in it. So Poisson's ratio is used over there. Also, when we know two properties in an isotropic material, we can find its other properties. For example, bulk modulus or modulus of rigidity. If we know Poisson's ratio, then Young's modulus.
Okay, and Umar, can you tell me when we draw Mohr circle, what additional things we get in the Mohr circle?
Sir, we can get stresses on different planes. We can also get maximum stresses or the principal stresses. We can also get the maximum shear stress and their orientation as well. For example, on this plane which stress is taking place, and it is orientation with the reference or any direction.
What do you mean by principal stress?
Principal stresses are maximum or minimum normal stresses that act at a point in multi-axial state of stress.
Why do we calculate principal stresses?
Sir, because our design of any structural component will be based on the maximum stresses. So in order that the stresses do not exceed a certain limit, we calculate the maximum stress in it so that we have the idea of how much stress can the body withstand.
Okay. Okay, now Umar, if I ask you something about theories of failure,
Yes, sir.
can you tell me which theory of failure will you use for mild steel?
Sir, mild steel is ductile, so we will use maximum shear stress theory or distortion energy theory.
And for brittle, what theory do you use?
For brittle, we will use maximum principal stress theory.
Okay, deflection of the beam.
Yes.
What theories do you use to analyze deflection of the beam?
Sir, deflection of a beam can be, for example, we use the flexural equation that states the flexural rigidity into multiplication of double derivative with respect to the x is equal to the bending moment or negative of the bending moment. So then we integrate it twice to get the deflection profile.
And what is Macaulay's equation?
Sir, Macaulay's equations, I do not know properly, but I think these equations use the singularity functions to find the deflection. So singularity functions are actually defined for a certain length.
And how do you define moment of inertia?
Sir, moment of inertia is used in bending equation. Sir, if we define moment of inertia with respect to the structures, it is defined over the cross section, and it is given by the double integral of y square dA. So
what is section modulus?
Sir, section modulus is moment of inertia divided by the distance from the neutral axis, maximum distance, the outer fiber of a beam.
Okay. Okay, Umar, let me give the feedback. Umar, you have revised this subject, that is good. Machine design ke liye you can go for a snap with the Gaurav sir.
Yes, sir.
If you want with machine design, then you can go for machine design with him. As far as strength of material is concerned, you have revised the subject, that is there. But
Yes,
I'll advise you that you keep revising the marathon and technical snaps of strength of material, right?
Yes, sir.
So the question which I've asked you, you have answered those questions. That is okay. That means your knowledge of this subject is good.
Yes, sir.
I did not find any question which you were lacking. That was okay. Only thing is now revise other subjects also, because all engineering subjects you should have some knowledge for assistant engineer post.
Yes, sir. Sir, actually, sir, I have been working as a teacher for a long period of time. I mean, should I prepare for only those subjects? For example, I might be asked which subjects I have been teaching, and then focus on.
No, it is not like that. It is not like that. They may ask you the subject, because if some teacher of some particular subject is sitting there, he will certainly ask you question from his subject. Sometimes they invite professors also, no? Just imagine that professor of production engineering is there.
Yes, sir. Yes.
He may ask you question from production.
Yes, sir.
Basic question he
Yes,
might
sir.
ask you.
Yes,
So
sir.
I think in assistant engineer, he does not go in depth. So basic knowledge of the subject you should have.
Okay.
Yes.